this is the last stage of our analysis. So we need different types of data, like a return of the portfolio, covariance matrix, Sharpe ratio, and this data will help you to construct the Bayesian frontier. Previously we have shown you how to find out the return of the individual, security, and also the portfolio return, portfolio standard deviations, and covariance matrix. So we'll use this data here. So this is the covariance matrix data that we have constructed earlier. So just copy it here and paste it here. We will need this data later. Okay. And we also need to reconstruct our return data, standard deviation data, and here return data, and then we'll put here the weight means the proportion of fund you need to invest in each of the stock. So we have for stock W, X, Y, and Z, this for stock. So this is the annual return data. So you need to transpose it here. So in order to transpose it, first you need to copy this one, then paste it in any place. You say this is 000, so just simply click here paste options, or just select there paste option and click balance and number formatting. Okay, so again you can get your data, exact data. So now copy it here, then select this cell, select right button, paste special, transpose. Okay, so data has been transferred here. So after transposing the data here, we need to put weight. So you know the weight must be equal to 1 or 100%. So hypothetically we are putting the weight here, so you don't need to worry this. First you need to put any weight, but you must ensure that the sum of this weight must be equal to 1. So let's start. That is, the first one is 0.5, 50%, then 30%, then 10%, then 10%, and here is the sum of weight. Okay. Sum of weight. So you know the sum of weight should be equal to 1. So we sum this for weight and we got 1. So make sure the sum must be 1. So you need to put to weight of this stock based on your assumptions or based on your consideration. So we got here 1, and we also need risk-free rate. So here is the risk-free rate. So where can you find this risk-free rate? It is available on the website of central bank. So here for Bangladesh, it is the Bangladesh Bank website. Here you can see it here. So here you can go to the monetary policy and operation. Under this you can find treasury bill and bond auction. Click here. So there are different rate for different period, like 91 days, 182 days, 5 years treasury bond, 10 years treasury bond. So there is a debate which rate should you use here. So we'll discuss it later, but here we will use this 91 days treasury bill rate. So you see 91 days treasury bill rate is 7.74. Use this cutoff yield rate. Okay, 7.74%. For simplicity we consider it 8%, that is 0.08. So we put the data here 0.08. Now we'll find out the return of the portfolio. So this formula we have already used before, how to find out this return of the portfolio. So formula is m mult first bracket transpose first bracket weight of the column, this 4 1, then closing of the first bracket, semicolon, then return column, that is the return column, closing of the first bracket, and press shift control enter. Okay, so we got here return of the portfolio. So at this stage we'll find out the standard deviation of the portfolio. First you need to find out the variance of the portfolio. Variance portfolio. So here is the formula, you know this, M mult transpose, then you have to select the weight column, this one, closing of the first bracket, semicolon, M mult first bracket, covariance matrix, you have to select this covariance matrix, then semicolon, then weight column again, this 4 1, then first bracket, and shift control enter. Okay, you got the variance of the portfolio, and you want to need the standard deviation of the portfolio also. So just square root of this variance, so is equal to sqrt square root, this one, this is the variance. So you want to do the square root of this variance, press enter. So this is the standard deviation of the portfolio. And now we want to find out the Sharpe ratio. Here is the Sharpe ratio. So the formula is Sharpe ratio, you know this, return of the portfolio minus risk-free rate divided by standard deviation of the portfolio. So return of the portfolio minus risk-free rate divided by standard deviation of the portfolio, enter. So you get here the Sharpe ratio. So efficient frontier, we have discussed earlier that the way you can construct the efficient frontier, so you need to maximize this Sharpe ratio while the sum of weight should be 1. So the maximize the Sharpe ratio will help you to construct an efficient frontier. So now we will use the solver function to maximize this Sharpe ratio. So again you need to go this tools options, then solver. We have discussed earlier how can you bring this solver option here. So click solver function. Here is the solver parameters, you can see it from here. And first one is set the target cell. Okay, set the target cell. So you want to maximize your Sharpe ratio, that is your target. So your target cell will be the Sharpe ratio. Where is Sharpe ratio? This cell. This is the Sharpe ratio, that is your target cell. So we have select here, then click here. So this is the target cell. So what do you want? You want to maximize this, so click the maximize, and it will be as usual, that is the default option. And you want to maximize this Sharpe ratio by changing your weight. So by changing cells, which cells? That cells which contains the weight. So click here, you need to select this weight options, these cells, click here. Okay, but you have one constraint, that is the weight, the sum of your weight should be 1. So this is the constraint option. So click add, cell reference, which cell one? The sum of the weight. Where is sum of weight? Here, this cells, this is the sum of weight. We have find out earlier, this is 1, so it should be equal constraint 1, it should equal to 1, and then press enter, it is added here. So now click solve, you see solver found a solution. Okay, so solver found a solution. Get OK. So this is the weight, you see the change of weight. Previously we have put some hypothetical weight, and this is the actual weight that should be used in real scenario. So in this sense, your Sharpe ratio will be maximized to around 300.93 point, and among your total fund you need to invest 93% of your total fund into asset W, around 6% fund in asset X, around 12.43% Y, and this is the minus, you see minus 0.11. so minus mean disinvestment that comes with short sell. So this weight, this will tell that you need to short sell also. Okay, so in this way we can find out the desirable weight that you need to invest in each stock, and that will maximize your Sharpe ratio. But problem is here that short sell is not allowed in most of the countries, especially for the developed countries. It is allowed, but in developing countries or underdeveloped countries this short selling isn't allowed. So in that case you have to put some more constraint there. So no weight should be negative. So if you can make that ensure, then there is no option of short selling. So how we can do that again? For in that case of not short selling, we'll go tools option, then solver. So it is the previous constraint that we have put here, it will not be changed, it will be same as we have input data earlier, but we need to add more constraints. So we need to change it here by adding more constraint. So click add option. First constraint is to we need to make weight is equal to or greater than 0. So no negative value of weight is acceptable. So my cell reference first weight, then it should be greater than or equal to what? 0. Okay, then press enter. Then again add options, then cell reference second weight, it is also greater than or equal to 0, then enter. Then add options, then cell reference, this is the third weight, it will be greater or equal to 0, press enter. And last, for the last security, add cell reference, this one, it will be greater or equal to 0, enter. So we got these options and press solve. Okay, solver found a solution. Okay, so you got here there is no negative weight. Okay, so if short sell not allowed, then we need to put some more constraints and we will get this value. So this is 0, that means so you don't need to invest your fund this security, and you need to invest your fund in all those 3 securities. Okay, in this way we have found our efficient frontier that contains the best possible weight that will be invested in each security.